Now we'll look at 13. It says a computer engineer is hired for a salary of $28,000. If she gets a 5% raise each year, after how many years will she be making $50,000 or more? So we're talking about an increase in salary, so this is a growth. Okay, it's exponential growth. Okay, A is going to be my starting salary, which is $28,000. This is your R, 5%. Now, to make 5% a decimal, that's equivalent to 0.05. So R is going to be 0.05. And then Y is going to be my ending salary. We want to know when she gets to 50,000. Okay, so I'm going to use the growth one, Y equals A times 1 plus R to the T power. That's exponential growth. My ending amount is 50,000, so on this side I'm going to put 50,000. My beginning amount is 28,000. And then I'm going to put 1 plus 0.05 inside here, which is 1.05 is what I'm going to get inside there. So I'm adding these two together right now, and we're trying to figure out T. How many years, that's what we're trying to find, is T. Now, notice we've got this 28,000 out here in front. We've got to get down to just the 1.05 T by itself. So my first step, and this will always kind of be the first step when you got to, is to get rid of your A amount or your initial amount. We're going to divide both sides by 28,000. And if I divide both sides by 28,000, I get 1.786 on this side equals 1.05 to the T power. Now, you can't divide, that doesn't say 1.05 times T. You have to use a log to solve, because we're trying to solve for a variable that's in an exponent. This is just like what we've done now in the last few sections. We need to take, and this won't be natural log because we're not dealing with base E now, we're going to take the common log of each side. So the log of 1.786 equals the common log of 1.05 to the T power. Now, if you think about the logarithm properties we've talked about, this goes down in front and becomes T times the log of 1.05. And here I have the log of 1.786. I'm going to go ahead and put that in parentheses. Now to solve for T, I divide by the log of 1.05. Divide by the log of 1.05. And that will give us T, or the number of years. So on your calculator, you're going to use your common log button, log of 1.786. Again, I'd hit equals, and then divide by the log of 1.05. And that should work out to be about 11.9 years. Okay, if you went to the nearest year, it would be 12 years, which would be acceptable. I like one decimal place on most of these. Okay, let's go down. Last one we'll look at here is number 21. It says a GPS system uses satellite information to locate ground position. John's surveying firm bought a GPS system for $12,500. The GPS system depreciated, okay, which tells me it's going to be decay. It's going to go down in value, okay, at a fixed rate of 6%, and is now worth $8,600. How long ago did John buy the system? So we're looking for T. So we're going to use our exponential decay equation, y equals a times 1 minus r to the power of t. Okay, the initial amount, there's y, it's 12,500. That goes on this side. Okay, I'm sorry, that's the ending. Oops, I got that backwards. Let's undo that. That is the initial amount, the 12,500 goes here. This is really A. The ending amount, because it's going down in value, is 8,600. That goes here. It's 6%, which is equivalent to 0.06. So if I do 1 minus 0.06 inside parentheses, that is 0.94 to the power of t. Now, to solve this, we're going to have to get the 0.94 to the power of t alone. We divide by that 12,500. So again, you're dividing by that A value, or the initial amount. So on this time we're going to get a decimal less than 1 over here. We get 0.688, if you do the calculator work there, equals 0.94 to the power of t. Now we're going to do the common log of both sides, so the log of 0.688 equals the log of 0.94 to the power of t. Let's slide this down. This goes down in front, so this side becomes t times the log of 0.94 equals the log of 0.688. Now we're going to divide by that log of 0.94 to get t alone on both sides, dividing by that log. So if I do the calculator work, log of 0.688, hit equals on my calculator, leave that in display, divide by the log of 0.94, and we should get about 6.0 years. So it would take about 6 years for it to depreciate or go down in value to 8,600.